In Chapter 2, we're going to learn how to summarize data and graph data. Make sure you read the chapter so that you can pick up on all the information, but I'll go over some of the most important things in this PowerPoint that you'll be tested on potentially. Some important characteristics of data that are outlined in this unit are the center of data. The center is an average value that indicates where the middle of the data set's located. And there's several different types of centers that we'll actually discuss in this unit. There's also variation. Variation is looking at the measure of the amount that the data values vary. And then distribution. Distribution looks at the shape of the data over the range of the values. So if we graph the data, does it have a bell-shaped curve? Is everything exactly the same? So is it uniformly distributed? Or is it skewed? Is it stretched one way or the other? And then sometimes we have outliers, and those are sample values that are far away from the vast majority of the other sample values. For instance, if most of our values are within the range of 1 to 10, and then we have a value of 30, 30 would be an outlier. And then time. We look at changing characteristics of the data over time, and we can do that using a graph usually. Something that you'll need to know and be really familiar with for the first exam is a frequency distribution. A frequency distribution is a table that displays a list of categories that are called classes, and then it has tallies of each of the categories listed in that table. And so I'll reference table 2.2 on page 47 when we do these examples here. But some things that we need to know about the table is the lower class limit. The lower class limit is the smallest value within each class. So if the first class goes from 21 to 30, 21 would be the lower class limit. And then the upper class limit is the larger number, or the upper number, in each class. Class boundaries. These are the numbers that are used to separate the classes, but without any gaps created by the class limits. And so I will go through the mathematical way of how we calculate the class boundaries. And then class midpoints. These are the middle values of each class, and there's a way to calculate that. And then the class width. Class width is how much it's jumping up by. Does it go up by 10? Does it go up by 5? So we'll look at how to calculate that. Here's an example of a frequency distribution that's taken out of your textbook. Here we have ages of actresses who won the Oscar for Best Actress. Now if you look at the highest amount, that would be 30, that would be the age range of 31 to 40 years old. So some examples here, the number 21 is a lower class limit. So we have one class is 21 years to 30 years, and we had 28 as the frequency. So 28 actresses who got the Oscar were in that age range. The upper class limit for the first class is 30. Okay, class boundary. One class boundary that we could calculate is 60.5. And that's from going, we notice that the class jumps from 60 to 61, so that's a gap of 1. We divide the gap, so 1 divided by 2 is 0.5. And so what we do to create the boundary is we go up 0.5 from the upper limit and go down 0.5 from the lower limit. And we'll do more examples of that on the next page. A midpoint. How do we find the midpoints of each class? Well, what we do is we add the lower number with the upper number, and we divide it by 2. So 41 plus 50 is 91, and 91 divided by 2 is 45.5. So 45.5 would be the midpoint of that particular class. And then we have our frequencies, which are listed in the second column of the table. And so the number 12 indicates that there are 12 actresses who were aged 41 to 50 that got the Oscar for Best Actress. Another value that you'll be able to calculate is the class width. And one class width we notice is going from a jump from 70 to 80, so that's 10. The width is always vertical, so what we're doing is we're saying, okay, look at the lower numbers, and it's going up by 10 each time. And you should always have a systematic approach to this, so the upper numbers also go up by 10. So the class width for this table is 10. This example is like problem 5 on page 53. So this is a really good practice question for what you'll see on your test. Here we have a frequency distribution table showing daily precipitation in inches, and then we have the frequencies, how that was measured, and what we want to do is identify the class width, the class boundaries, and the class midpoints. So here's how we do the class width. We do this by finding out how much is it going up by. So you can take the upper numbers like 0.99 and 0.49, and you can subtract that and you get 0.5. Or you can also take the lower numbers. The first class starts at 0, the second class starts at 0.5, so it's going up by 0.5 each time. So remember, width is how much is it going up by each time, vertically. Each class has a midpoint, so when you're asked to calculate the midpoints, you have to do it for each class. So the first class, we add 0 with 0.49 and divide it by 2. We get 0.245. Second class is 0.5 plus 0.99. Divide that by 2 is 0.745. And by the way, if you're typing this in your calculator, make sure you type it in the way you see it on the screen, including the parentheses around the numbers that you're adding. If you don't put the parentheses around it, you will not get the correct number. Okay, so then we have the rest of the class midpoints here, where I'm just adding the lower number with the upper number and dividing by 2. Now what's really interesting that I want you to look at is that if you take the first number that we got was 0.245, that first midpoint, and if we take the class width is going up by 0.5 from class to class. Well, once you find that first midpoint, what you can do is you can just keep adding 0.5 to it, and you'll get the rest of the midpoints. So that's another way to find the midpoints. Find the first one, and then add the class width to each successive one. Okay, the class boundaries are going to really help us when we graph a frequency distribution. And so each class increases by 0.01. How do I know that? Well, I take the number that it ends with. So the first class ends with 0.49, and the number that the next class begins with is 0.50. So that's a jump of 0.01 or 1/100th. So each class is jumping by that much from the end of one class to the beginning of the next. And then what we want to do is half that number. So divide that by 2 and you get 0.005. Third, the boundaries are created by backing up 0.005 from each lower limit and increasing 0.005 to each upper limit. And what that does is it creates no gaps at all, and one class picks up with the next one. So here's what you would get for all of your class boundaries. The first one, it starts at 0, but we're going to subtract 0.005. So the boundary would be from negative 0.005 to 0.495. So I'm adding 0.005 to 0.49. Now, if you take the next class, which starts at 0.50, if you subtract 0.005 from 0.50, you get 0.495. And then we add 0.005 to the upper number, 0.99, and we get 0.995. So if you look at all of these boundaries, you'll see that it always picks up where the other one left off. So the third class boundary picks up at 0.995, and then it goes to 1.495. Picks up at 1.495, goes to 1.995. How do we construct a frequency distribution on our own? Well, you first select the number of classes that you want. So you might have a textbook problem assigned to you in the homework where you have to do this and get practice with this, and it will tell you how many classes to set up. Then you calculate the class width. And so the class width An appropriate way to measure that is you take the highest number in your data, subtract the lowest, and divide by the number of classes. Like if you wanted to split it up into 10 classes, this gives you the width. Select the lower limit, or it could be either be the smallest value if that's a nice number, or you can round it. And then add the class width to each lower limit. So if you're going up by 10 each time, you just add 10 to each limit until you get all the pieces of the data. Write all your classes in a vertical column, and then tally up. Now, another type of frequency distribution is a relative frequency distribution. So you also need to know this for your next test. A relative frequency distribution lists percentages instead of individual counts or tallies for each class. How do we find those percentages? Well, we add all the tallies together to find the total count, the total frequency, and then what we do is we take each individual class tally and divide it by the total and convert that to the percent. So we'll do an example on the next page for a relative frequency distribution table. So here we have the frequency distribution table of ages of best actresses, and what we want to do is convert this to a relative frequency distribution. The first step is to find the total of the frequencies. So you're going to add the numbers that you see in the tally column. We add 28, 30, 12, 2, 2, and 2, and we get 76 total people. Next, what we do is for each frequency, we divide it by 76. So 28 out of 76 is 0.368. 30 out of 76 is 0.395. 12 divided by 76 is 0.158. And so on. Now these decimals are not in percent form yet. So here's our table. Notice that it's labeled exactly the same way, except the second column now says relative frequency instead of just frequency. And then also notice that I took all of my values and I converted it to a percent. So I rounded everything to 3 decimal places, but if you want to round it to whole percents, that's also okay. So let's practice again, and we'll make a relative frequency distribution of this table of daily precipitation levels. So the first step is to add up the total frequencies. So if I add that column, 31, 1, 0, 2, 0, and 1, I get 35. Next, we take each individual frequency and divide it by the total, 35. So 31 out of 35 is 0.886, 1 out of 35 is 0.029, 0 out of 35 is 0, 2 out of 35 is 0.057, 0 out of 35 is 0, and 1 out of 35 is 0.029. Then we set up our table, and the first column is exactly the same with the classes that are labeled. The second column, though, says relative frequencies, and we have percentages. And so 0.886, we move the decimal 2 places to the right, that's 88.6%. The second number, 0.029, if we move the decimal 2 places to the right, we get 2.9%. And we continue doing our percentage conversions to fill in the table. Here we want to make a cumulative frequency distribution for this table. So with a cumulative frequency distribution, what we do is we take that original frequency distribution table and we make a new table, but let's look at what changes. The heading says cumulative frequency distribution, and notice that the first column, it no longer says the classes of 21 to 30, 31 to 40, 41 to 50, and so on. Instead, it says less than 31, less than 41, less than 51. So that's an important thing to change. Next, we have the cumulative frequencies. Notice that the first one is 28, but the second one is now 58. So how did we get from 28 to 58? Well, what we do is we take the first class tally, which is 28 people, and we add the next number below, which is 30. So 28 and 30 is 58. And what we're doing is we're just keeping a running tally. So if we read it now, it says that how many people were less than 41 years old? Well, that would be 58 people, because we're adding 28 and 30. To get the next number 70, we take 58 plus 12. And then we add 2 to get 72. We add 2 to get 74, and then we add 2 to get 76. And then here's another example of a cumulative frequency distribution taking the original table. So notice that it's very important to remember that the first column should say less than. Okay, and then what you're doing is the number that you're picking to be less than is the number that the second class starts with, or the next class starts with. And then we have cumulative frequencies. So the very first number is 31. We start with 31 in our table. Then we add the next number in the list, which is 1. 31 and 1 is 32. Then we add the next number in the list, which is 0. So we get 32 again. Then we add 2 to get 34. We add 0 to get 34 again. And then we add 1 to get 35. Let's construct a relative frequency distribution for this example. So this is example 16 on page 53. In a study, researchers treated 570 people who smoke with either nicotine gum or a nicotine patch. Among those treated with nicotine gum, 191 continued to smoke, and the other 59 stopped smoking. Among those treated with a nicotine patch, 263 continued to smoke, and the other 57 continued smoking, or stopped smoking. So the solution to this is on the next page. So here you can see that the categories are set up based upon the information they gave us. People who continued smoking after nicotine gum treatment, those who were not smoking after nicotine gum treatment, and then I just put my frequencies. So the way I did my frequencies is I knew that it was 570 total people in the study, and then what I did is I took each number that was given to me and I divided it out of 570. So the very first number that goes with those who smoked after nicotine gum treatment, that was 191 people. So 191 divided by 570 is about 33.5%. Here we have listed below some amounts of strontium-90, which is a radioactive substance that was found in a simple random sample of baby teeth obtained from Pennsylvania residents born after 1979. Construct a frequency distribution with 8 classes. Begin with a lower class limit of 110 and then use a class width of 10. And cite a reason why such data are important. So notice that they're guiding us here. We know we want to divide the data into 8 classes, and we know we want to start with 110. So what I'm going to do then is set up my table on the next page. So you can see here that they started me off with 110, and it says that I want to have a class width of 10. So I knew that my next class had to start with 120, and then 130, and then 140, and so on until I contained all my data. Now the highest number in my data, I think, was 188. So I knew to stop at 180 because that would contain all of my data. And then it's really easy to end your classes if you know what it begins with. So my first class goes from 110 to 119, then it picks up 120 to 129, and so on. Now the frequencies were obtained by looking at my actual data and counting the number of values that were from 110 to 119. And so I just had 2 numbers that were within that class. So you count the frequencies of the numbers that occur within each class and record those.